Good morning, students. I welcome back you all to this mathematics class, and we are dealing with chapter 2 of class 12 mathematics inverse trigonometric functions. Now today we are going to do miscellaneous exercise, and as you know that the syllabus has been trimmed, so all the questions we are not supposed to do. We are supposed to do only those questions which are related to domain and range, but we are going to do a few more questions that are going to be used in differentiation and integration. So now let us concentrate on first question. This is cos inverse 13 pi by 6, and you have to find the value of this. Now most commonly students have a tendency that they write cos inverse 13 pi by 6 to be 13 pi by 6, which is wrong. Now let me explain you why this is wrong. Because whatever value of this function you are going to get, that value should belong to the principal value range of cos inverse x, and the principal value range of cos inverse x is 0 to pi. So that means if I write the value, if you write 13 pi by 6, it should belong to 0 to pi, and which is not happening. You can see that this 13 pi by 6 is not belonging to 0 to pi. So what should you do is that you should try to write this cos inverse cos 13 pi by 6 as cos inverse cos 13 pi by 6 can be written as 2 pi plus pi by 6. Now students, you recall the coordinate geometry, the trigonometry that you have studied in your class 11. As per that, these are four quadrants: first, second, third and fourth, and the angle 2 pi plus pi by 6. So this is 0, and this is the direction of the spiral, and here is the point 2 pi. So any angle 2 pi plus pi by 6 is going to belong to first quadrant. So this angle 2 pi plus pi by 6 is in first quadrant. And you know that in first quadrant all trigonometric ratios are positive. So the result of cos inverse, now we have to write the result of cos 2 pi plus pi by 6. So cos 2 pi plus pi by 6 is going to be cos pi by 6. Now cos pi by 6 means cos 30 degree, and the value of cos 30 degree is root 3 by 2. So in place of cos pi by 6, I substitute its value, that is root 3 by 2. Now you have to find out the value of cos inverse root 3 by 2. So at what angle will cos inverse root 3 by 2, at what angle will cos theta give you the value 3 by 2? You can understand it in this manner, that this is that angle at which cos theta is going to give you the value root 3 by 2, and that is going to happen at 30 degree only. So its result is pi by 6. Now once you get the value of the given function, given inverse function, you have got the value pi by 6. You have to check whether this value pi by 6 is it belonging to the closed interval 0 to pi, because the principal value range of cos inverse function is closed interval 0 to pi. Yes, it is very much belonging to 0 to pi, and this implies that the required value of the given trigonometric inverse trigonometric function is pi by 6. Now we move to the second question. Tan inverse 10 7 pi by 6. So whatever value you get from this function, it should belong to this open interval minus pi by 2 to pi by 2. And directly I cannot write the value 7 pi by 6. Sometimes students make this mistake that they directly write the answer to be 7 pi by 6. But this is wrong. Why? Because 7 pi by 6 does not belong to the open interval minus pi by 2 to pi by 2. And therefore I write tan inverse tan 7 pi by 6 as pi plus pi by 6. Now pi plus pi by 6 comes in third quadrant, and in third quadrant tan inverse, in third quadrant tan function is positive, and therefore the result is tan pi by 6. Now tan pi by 6 means tan 30 degree, and hence we have 1 by root 3. So the value of tan pi by 6 is 1 by root 3. Now tan inverse 1 by root 3 means we have to write that value of tan theta at which it is 1 by root 3. Or if you don't know how to solve after this, you can assume it to be y. Then 1 by root 3 will be equal to tan 1. So what should be y? Y should be 30 degree, or you can say pi by 6. Now you should check whether this value of y, that is this value of the given inverse function, is it belonging to the open interval minus pi by 2 to pi by 2? Yes, pi by 2 belongs to, pi by 6 belongs to the given interval. Now we move to question number 9 of miscellaneous exercise on chapter 2. Now here I can tell you students that from chapter 2 miscellaneous, question number 3 to 8 we are not supposed to do this year as the properties are not in your course. So these are the proof questions of properties which have no application in integration and differentiation. So we are not going to do these questions. Now in question number 9 you have to prove that tan inverse of root x is equal to 1 by 2 cos inverse of 1 minus x upon 1 plus x. Now here students should pay attention that whichever side is complex, we convert it that to the simpler one. So now here to do this question, we are going to start with RHS and we should prove that this RHS is equal to LHS. RHS is 1 by 2 cos inverse 1 minus x upon 1 plus x, and it is given to you that x belongs to the interval 0, 1. Now you have to make an appropriate substitution. So what substitution I am going to make? We can put x to be tan square theta. Why I have substituted x to be tan square theta? I am going to make such a substitution so that after substituting that in place of x, I am able to get some trigonometric formula. So I am going to get the trigonometric formula. You can see. Now this expression becomes 1 minus tan square theta upon 1 plus tan square theta. So now you must have recalled that this is the formula of, yes, you are very right, this is the formula of cos 2 theta. Now students, you can see cos inverse and cos. They are going to nullify the function of each other. They are not going to cancel. So we can write here the value of this expression is going to be only 2 theta. So 1 by 2 into 2 theta, and 2 gets cancelled and we get only theta. But now we have to substitute back theta because theta was not the variable given to you, but it was introduced by us. So how to substitute back theta? For that we go back to our substitution. We substituted x to be tan square theta. So now, as you know that x belongs to the interval, it is given to you that x belongs to the closed interval 0 to 1. That means x is greater than 0 or equal to 0 and less than or equal to 1. That means if x is positive, so its square root is also going to be positive. So it is not going to take any negative value. So we are considering only positive square root. Now you transpose this tan function on the LHS. So tan function becomes tan inverse function. And we get tan inverse root x is equal to theta. If root x is tan theta, then tan, if it acts on LHS, it will become tan inverse of root x is theta. That means the value of theta is coming out to be tan inverse root x, which is equal to left hand side. So now students, you have proved that the right hand side is, and it is equal to the left hand side, and hence we have proved. Let us move to question number 10. Now one thing you should note that these questions, question number 9, 10 and 11, they are necessary for you to do 9, 10, 11 because you may use them in, you may require them in your differentiation and integration. So now 10th question says that you have to prove that cot inverse of 1 plus sin x 1 minus sin x upon root 1 plus sin x minus root 1 minus sin x is going to be x by 2, and this is very important. It is given to you that x belongs to 0 to pi by 4. So now what is the use of this domain x? This I am going to explain. First let me start with the question. This is cot inverse. Now what I am going to do, see, 1 plus sine x. Can you write 1 as sine square x by 2 plus cos square x by 2? I have written this one. You can see this one has been written as sine square x by 2 plus cos square x by 2. Also, this sine x, you can see this sine x. This can be written as 2 sine x by 2 into cos x by 2. So what we have done, the first bracket root of 1 plus sine x has been written as in this form. Sine square x by 2 plus cos square x by 2, this is 1, and 2 sine x by 2 cos x by 2, this is sine x. Plus, now we move to the other bracket, this one, root of 1 minus sine x. So here again 1 can be written as sine square x by 2 plus cos square x by 2, and sine x can be written as 2 sine x by 2 into cos x by 2 divided by, now this third bracket root 1 plus sine x, this can be written in the exactly in the same manner as we have written above. 1 can be written as sine square x by 2 plus cos square x by 2, and sine x is plus 2 sine x by 2 into cos x by 2 minus square root of sine square x by 2 plus cos square x by 2 minus 2 sine x by 2 into cos x by 2. So we have written all the 4 square roots in this form. So why we have written in this all of them in this form is, now you will get to know. Now see this expression that I am underlining it here. Now whatever is written inside the square root, isn't it the whole square of sine x by 2 plus cos x by 2? Yes, it is the whole square of that. Now look at this that I am underlining with blue. This is the whole square of, this is the whole square of either cos x by 2 minus sin x by 2 or sin x by 2 minus cos x by 2. But why I am choosing here cos x by 2 minus sin x by 2 is because in this range, it is given to you that x is between 0 to pi by 4. In this range, cos x is greater than sin x. I will show you after this question, after I finish the question from the graph also, that from 0 to pi by 4, the value of cos x is more than sin x. So to make the square roots positive or to get the positive value, I have taken here in this and in this the whole square of cos x by 2 minus sin x by 2. I think you are able to understand what I am saying here. In place of this bracket, you could have written sin x by 2 minus cos x by 2 also. But you chose to write cos x by 2 minus sin x by 2 because you want to write here only the positive value. Positive value means if you are writing cos x by 2 minus sin x by 2, so it should be greater, sin x by 2 should be greater than, cos x by 2 should be greater than sin x by 2. And in this domain, cos x is greater than sin x, and hence we are choosing this value. And divided by square root of sin x by 2 plus cos x by 2. So now you can see, after substituting all the expressions with their whole squares, I get this value. Now you see, in all the four square roots, whole square and square root, they nullify each other. So this function becomes sin x by 2 plus cos x by 2 plus cos x by 2 minus sin x by 2, because in every square root has been nullified by the square. Square and square root cancel each other. Here also sin x by 2 plus cos x by 2 minus cos x by 2 minus sin x by 2. Now we can cancel sin x by 2 with sin x by 2 here, and we can cancel, you can see cos x by 2 with cos x by 2 here. So we are left with cos x by 2 plus cos x by 2 becomes 2 cos x by 2, sin x by 2 minus minus plus sin x by 2 becomes 2 sin x by 2. 2 and 2 they get cancelled, and you get cot inverse cos x by 2 upon sin x by 2 is cot x by 2, and cot inverse cot get nullified, and the result comes out to be x by 2, which is your right answer. If you want to see the previous view, I can show you. I am waiting here for a minute, you can note it down. And if you want to see anything from the previous part, you can move from here. Now students, I have made the graph of the sine function from 0 to pi on the right hand side and 0 to minus pi on left hand side. Now on the same Cartesian plane, if I draw the graph of cos x, why I am doing this? I am going to explain you why I took cos x by 2 minus sin x by 2 and not the other way. This is I am going to explain. So on the same graph sheet, now I draw the graph of cos function. Now you can see on the same graph, I have drawn the graphs of sin x and cos x. You can see this black graph, which I am underlining with yellow color. This is the graph of this black one. This is the graph of sin x, and this one, that red one, this is the graph of cos x. Now I have to study the behavior of these two graphs together. Now as you people know that the common value that these two functions sin x and cos x have, they have its pi by 4, because as you know, sin pi by 4 is also 1 by root 2 and cos pi by 4 is also 1 by root 2. That means at pi by 4, which is this point, they intersect. So this is the point on x-axis, pi by 4, and this is the value, if you consider it here, this is the value 1 by root 2. So now in the previous question, it was given to you that x was belonging to the interval 0 to pi by 4. So that means in the previous interval, you are going to consider x only from here to here. So from this portion to this portion, you have to see out of these two curves, red one and black one, which has got higher value. Higher value means which has got more height. The value of the graph, value of the function is measured by its height on y-axis. So it is very clear that the height of the red graph is more than that of the black graph. That means value of cos function, which is this, is more than the value of sine function, where only in the interval from 0 to pi by 4. Okay. Now suppose the range, this interval which is 0 to pi by 4, if suppose it would have been pi by 4 to pi by 2, sometimes the interval is given to you to be pi by 4 to pi by 2. So you have to study the behavior of the two graphs in this range also. You see, this is pi by 4 and pi by 2. So in this range, you can see the black one is on the upper side and the red one is on the lower side. So what do we conclude? We conclude from these two graphs is that from 0 to pi by 4, the value of cos x is more than sin x, and from pi by 4 to pi by 2, the value of sin x is more than cos x. This is the discussion, and what do we get from this discussion? That I explain you. So students, we conclude that if x belongs to 0 to pi by 4, if x is from 0 to pi by 4, then x by 2 will also be in the interval 0 to pi by 4. It cannot be negative. It cannot be less than 0. So in this interval, we have seen right now in the graph that the value of the cos graph is more than the value of sine graph. And because x by 2 is also belonging to the interval 0 to pi by 4, therefore value of cos x by 2 is going to be more than the value of sin x by 2, and therefore cos x by 2 minus sin x by 2 is going to be greater than 0. And this is the reason, students, why I took square root of 1 minus sin x as cos x by 2 minus sin x by 2 whole square. Whereas root of 1 minus sin x can also be written as sin x by 2 minus cos x by 2 whole square. This is going to be written when x belongs to the interval 0 to pi by 4. And this is going to be written when x belongs to the interval pi by 4 to pi by 2. So it depends upon the interval that how are we going to write this expression. This concept is used many times in differentiation as well as in integration. So now you have to learn up all these concepts by your heart. I can once again show you the figure. Note it down. This was the figure, and this is what we have concluded from this figure. Now we move to question number 11 of miscellaneous exercise on chapter 2. Now here also you have to prove that tan inverse root 1 plus x minus root 1 minus x upon root 1 plus x plus root 1 minus x is equal to pi by 4 minus 1 by 2 cos inverse x. So we start with LHS, and as you can see the hint is given to you that you have to put x to be cos 2 theta. So in LHS I am substituting in place of x, this x at the 4 places. I am going to substitute x to be cos 2 theta. So what do I get? I get 1 plus cos 2 theta, 1 minus cos 2 theta, again 1 plus cos 2 theta plus 1 minus cos 2 theta. Now students, you have to recall your trigonometry of class 11. So you must be remembering that the formulas that you have studied in your class 11, according to that 1 plus cos 2 theta can be written as 2 cos square theta, and 1 minus cos 2 theta can be written as 2 sin square theta. So let us substitute these values in the question, and we get tan inverse square root of 2 cos square theta minus square root of 2 sin square theta divided by again 2 cos square theta and 2 sin square theta. So this expression becomes tan inverse root 2 cos theta minus root 2 sin theta divided by root 2 cos theta plus root 2 sin theta. Now we write the next step. Root 2 can be taken common from the numerator and denominator. So we get in the numerator cos theta minus sin theta, after taking root 2 common, and denominator is root 2 cos theta plus sin theta. Root 2 gets cancelled. Now you divide the numerator and denominator by cos theta. What we are doing? Dividing the numerator and denominator by cos theta. So what do we get? We get 1 minus tan theta upon 1 plus tan theta. And as you very well know that 1 minus tan theta upon 1 plus tan theta, this is the expansion of tan pi by 4 minus theta. Now here you can see that tan inverse and tan, they get nullified and you get the result as pi by 4 minus theta. Now we have to, students, substitute back. We have to substitute back the value of theta. So now you can see that we made the substitution. What substitution did we make? We make the substitution x to be cos 2 theta. This was our substitution. So that means if you transpose x on the cos function on the left hand side, it will become cos inverse x. So theta is 2 theta is cos inverse x. Divide the left hand side by 2, so you get 1 by 2 cos inverse x is theta. So the value of theta is nothing but 1 by 2 cos inverse x. So here in place of theta, we have got the value as pi by 4 minus theta. In place of theta, I will write 1 by 2 cos inverse x. So let me see, was this my right hand side? Yes, right hand side was this only, pi by 4 minus 1 by 2 cos inverse x, and hence also proved. Now students, let us move to question number 15. It is an MCQ and you have to find the value of the expression sine of tan inverse x. So let us assume that tan inverse of x is equal to theta. So that means this expression whose value you have to find, it becomes sine theta. What you have done, in place of tan inverse x, you have written theta because you have substituted tan inverse x to be theta. So now your aim is to find the value of sine theta. Okay, now let us come back to our substitution. We have made the substitution tan inverse x to be theta. So x is going to be tan theta. So x by 1 is going to be tan theta. So now what we do is, now let us consider a right angled triangle. You can see this right angled triangle ABC, and this angle is 90 degree. Let this is the acute angle theta. And if we apply, see here, tan theta is perpendicular upon base. So it's perpendicular, let us assume to be x, base let us assume to be 1. So what will be the hypotenuse? Hypotenuse is going to be root of 1 plus x square by the Pythagoras theorem. Now question says that you have to find the value of sine theta. So in the same triangle, if you want to write sine theta is perpendicular upon hypotenuse, which is x upon square root of 1 plus x square. Now you can see out of the given options, this value is given, matches to which option? I think option D is the correct option. Now let us move to question number 17. Now in question 17, you have to find the value of this expression. Now I am going to make a substitution. First of all, before the substitution, here in this expression, I divide the numerator and denominator by 1. So the given expression becomes tan inverse x by y minus tan inverse x by y minus 1 divided by x by y plus 1. Now after making this substitution, I will put x by y to be tan theta. That will give me that tan inverse x by y is going to be theta. Now let me make this substitution in the question. So now this question becomes tan inverse x by y becomes theta minus tan inverse. Now look, we have already written this step. So this becomes tan inverse x by y is tan theta. This x by y has been written as tan theta minus 1 divided by tan theta plus 1. Now theta minus tan inverse. You can take negative common. So you have 1 minus tan theta upon 1 plus tan theta. Now by using the properties of inverse functions, you can take this negative outside. So this becomes theta plus tan inverse 1 minus tan theta upon 1 plus tan theta. Now this is the expression for tan pi by 4 minus theta. Now as you can see that tan inverse and tan, they both nullify the effect of each other. So this becomes theta plus these two cancel the effect of each other. They are not cancelling each other, they are nullifying each other. So we got theta plus pi by 4 minus theta. Theta also gets cancelled and the result is pi by 4. Now you can see option C is the correct option. You can see the full question if you have to see. Okay, now with this I end up this class, and with the rest of the concepts I will meet you in the next class. Till then, keep revising and please don't forget to like, share and subscribe this channel.